Rounding percentages. We're going to complete the chart below for each test score. We're going to round the decimal value to the nearest thousandth. That's 3 places after the decimal point. And we're going to round percentages to the nearest tenth. So that's 2 places after the decimal point. So we're going to start by taking 30 divided by 40. So you'll notice now that they're not over 100 or 10 or 1,000. So in this case, we're going to have to take our numerator, which is our 30, and we're going to divide it by our denominator, which is 40. So 30 divided by 40 gives us 0.75. Because this only has 2 decimal places, there's no need to round it to the nearest thousandth. You could add a 0 at the end, but if there only is 2, then you don't need to go any further from there. In order to change this decimal number into a percentage, we are going to take the decimal number and we're going to multiply it by 100. And that gives us 75%. And again, because there are no decimal places, we don't need to add anything extra to this one. For our next example, our next fraction was 56 out of 60. I'm going to take my numerator, I'm going to divide by my denominator. That gives me a value of 0.9333333 and so on. What that means is that this 3 is a repeating decimal. So it goes on forever and ever and ever for the rest of time. So if I was to round this to the nearest thousandth, so that is this place right there, I would look to the right because it's a 3. I can just keep that as a 3. I don't need to round that digit up. So this would become 0.933. Now, sometimes you might see on repeating decimals a little dot or even a little line above the number or the numbers that repeat in that decimal number. So you might see that either as a dot or as a line. So keep that in mind as well. So if the number repeats forever and ever and ever, you may see that as an expression to represent that repeating decimal place. I'm just going to remove that from our answer though, because we're not going to worry about that too much for right now. So just 0.933 would be sufficient for this one. When we are converting this decimal value now into a percentage, I'm going to remember that I need to multiply this by 100. And decimal point, so 0.933 times 100 is 93.3%. So remember, when we're multiplying by 100, it's the same as moving our decimal place to the right 2 spots now. So that might be a good mental math strategy to employ. The last fraction or the last test score is 9 out of 15. I'm going to take my numerator of 9 and divide that by my denominator of 15. 9 divided by 15 is 0.6. So I don't need to worry about rounding because I don't have more than 3 decimal places. And converting that into a percentage, I'm going to times that by 100, and that will give me 60%. So to change from a fraction to a decimal, take your numerator and divide by your denominator. And then to change that decimal to a percentage, you multiply that by 100. Let's go through a few more examples. Example number 2, in a class of 25 people, 3 people are over 6 feet tall. What percent of the class is over 6 feet tall? So when I'm setting up my fraction, I'm going to write it as the number of people over 6 feet, so greater than 6 feet, over the total number of people. So in my case, I have 3 people over 6 feet, and I had 25 people in total. In order to convert that into a percentage, I'm going to first turn it into a decimal number. So I'm going to take my 3 and divide that by 25. That gives me 0.12. And then I'm going to take that decimal number and I'm going to multiply it by 100 to give me 12%. Because this is a word problem, I need a concluding statement. So therefore, 12% of the class is over 6 feet. And lastly, our second to last example, there are 1,800 tickets on sale for a concert. After the first day of sales, 1,350 tickets are sold. What percentage of the tickets are still available? So we need to figure out the number of available tickets. So this is one way to approach this question. So I'm going to take the total number of tickets I had, and I'm going to subtract the number of tickets that I sold. That gives me an answer of 450 tickets. So there are 450 tickets left. So when I'm creating my fraction to begin with, I'm going to write it as the number of tickets available over the total number of tickets I had to begin with. And then to change this into a percentage, I take my numerator, I divide by my denominator. That gives me 0.25. And then to change that decimal number into a percentage, I multiply it by 100. And that gives me 25%. So that's method number 1. Method number 2 So some of you might approach this question in a slightly different way. You might figure out what the percentage is of tickets that you sold. So this is number of sold tickets. So 1,350 over the total number of tickets in total. And you may want to choose to write this as a percentage first. So this becomes 1,350 divided by 1,800. And that gives us 0.75. Take that value, change it into a percentage by multiplying it by 100. That gives you 75%. So if that's how many tickets you sold, to figure out how many tickets are left over, you might go 100 take away 75 is equal to 25%. So my concluding statement, regardless of which method I chose, would be, therefore, 25% of the tickets are still available. And lastly, number 4, a basketball player made 12 out of 18 free throws. What was his free throw percentage? And we want to round the answer to the nearest tenth, so that's 1 decimal place. So I'm going to write this as a fraction, so the number of free throws made out of 18 free throws in total. I'm going to change that into a decimal number first. So 12 divided by 18 is 0.6666666. So this goes on forever and ever and ever. So again, an example of a repeating decimal. I'm going to take, it goes on forever. I'm going to take my 0.666 and I'm going to multiply, I'm just going to choose 3 for now. I'm going to multiply this by 100. And that gives me 66.66666 and so on. That's percentage, but I want to round this to the nearest tenth. So I have to look, okay, there's my value, my digit in the 10th place value. The number beside that is greater than 5, so this has to be rounded up. So it becomes 66.7%. So my therefore statement is, therefore, his free throw percentage is 66.7%. If you have any questions about this lesson, please reach out, send me an email, or sign up for a virtual help session, and I will see you in the next lesson.